Hi, my name is Kochie. I'm part of the Prometheus team, and today I'm going to be talking about the Prometheus monitoring system. A little background on me. I've been a system engineer for quite a long time, and I joined Google in 2005 and was an SRE there and learned how to do highly scalable applications and monitoring. I left Google a few years ago to move to Germany and joined SoundCloud, where some of my colleagues in the infrastructure team were starting to build this new monitoring software, because at the time we were hitting the limits of what we could monitor with the software that we had. And I'll talk a little bit about that next. And then just recently, a couple months ago, I left SoundCloud to join GitLab as their Prometheus development lead. So I'm helping bring Prometheus to GitLab itself, and also projects that are hosted in GitLab. So if you run GitLab, you'll be able to get metrics and monitoring out directly from your GitLab install, and that will be fully automatic. Just to start out, I was going to quick see who's using something like Nagios for monitoring. Lots of Nagios. Any other monitoring systems? Shout it out. I like being interrupted. Go ahead. Zabbix? Stackdriver? OpenNMS. Cool. What's that? Isinga, not yeah. Okay, cool. What's that? Sysdig, yep. Cool. So when you compare something like Zabbix and Isinga and Nagios, Prometheus is quite a bit different. We have a bit of an opinion about how monitoring should be done. So this is going to be a little strange for some of the traditional monitoring styles like Nagios. So it started out as a side project by a couple of engineers that were working for SoundCloud in 2012, and we started out as fully open source, and wanted to keep it as an open source project, so it wouldn't be SoundCloud specific. We didn't want that. How do I make this bigger? Can I make this bigger? No, I can't.
It's okay. It's okay. I think it's fine.
No, I'm trying to see what it looks like on my screen. And it was heavily inspired by monitoring systems that were used at Google, and was started by a couple of ex-Google engineers like myself. Just recently we joined the Cloud Native Computing Foundation as part of their family of open source systems. So what is Prometheus? Prometheus is a monitoring framework system for instrumentation, but it's more than that. It's also a time series database, and it stores statistical data, and it allows you to query that data, and it allows you to use that query language to do alerting. So not only do you get the alerting that you would get from something like Nagios, you also get all the statistics graphs that you want from something if you were using Graphite or InfluxDB, where you have a database of time series. So it provides both alerting and graphing. Back to that opinion, Prometheus is very much focused around operational monitoring. It's not a time series database for your business metrics. It's not a time series database for general use. It's very much a monitoring system focus. And it also is designed for very high dynamic environments, container schedules, VM elastic scaling, all the kinds of things where your applications are coming and going all the time. So what's cool about it? It has a dimensional data model and not a hierarchical data model. We have a very very powerful query language for doing statistical analysis. It's fairly efficient. And it's super operationally simplistic. It's a single Golang binary. You start it up. It has its own local data store. It reads a config file, and that's it. You're done. It's running. It's already up and running. There's no dependencies. There's no clustering. It's just really, really easy to start it up, and I'll demo that later. What does it not do? It's not an event system. You can't send logs to it. It's strictly a statistical collection system. We don't try and do any magic. We as experienced SREs discovered that trying to do too much anomaly magic just gets in the way. And if you go back to your fundamentals of what does your end user care about, what are your SLAs and SLOs, you can do that with just simple statistical analysis. So we do statistical analysis, but we don't do any magic statistical analysis. We're currently not focusing on super durable long-term storage. We have some projects to improve that kind of thing, but right now we don't do that. And we don't do auth and user management in the monitoring system. That's something that we just completely leave up to software that's better at it. We also don't do much on front end. Things like Grafana are way better than anything that we could build ourselves. So we follow the Unix philosophy of doing the one thing that we know how to do well and skipping all the rest and leaving it up to layering. This is the basics of the Prometheus architecture. Do I have a laser? I have a laser. The Prometheus server sits in the middle. It has the retrieval engine. It knows how to talk to service discovery. It does all the storage. It does all the query language, and it stores everything on disk in its own database format. It actually has two different databases. One database, which is just a simple level DB key value store for storing all the metadata, and then there's a very simple time series storage kind of. Yeah, I won't call it an RRD file, but it's basically time series and files. So what happens is, do I do that here? Yeah. The Prometheus server talks to your service discovery, whether it's coming from DNS or Kubernetes or console or EC2, or you can write out discovery files and it will dynamically read those. And that gets Prometheus knowledge about all of your things that need to be monitored. And then it connects out and pulls all of the software that you're running. So we call these jobs or exporters. And it can also pull other Prometheus servers. So there's a concept in Prometheus called federation, where one Prometheus server can extract data from another one in real time. And then there's also, if you have short-lived jobs, like cron jobs and things, you can push final results to a thing called the push gateway, which sits and listens for metrics. Once you start running and you've got all this data, then you use this PromQL, which is our query language, to get the data out and do the statistical analysis and put that up on dashboards with the web user interface or Grafana or other API clients. So like GitLab itself we're building a very simple graph engine into GitLab itself, so you don't need to install anything else. And it will just use the PromQL query API to get data back. And then it also has this thing, InfluxDB calls this continuous queries. We call them rules. And the rules are PromQL that are evaluated on a regular basis. And this is how alerts are generated. And the alerts are sent as messages to a thing called the alert manager. And the alert manager uses the data to send messages to email or PagerDuty or Slack or whatever. So here's the basic user interface in the expression browser. There's a sample. Oh wow, that's gonna be. I need to replace that image because that That is a hilarious piece of software. But it's basically, that's Bazooka up there is a container management engine, and this just gets you all the data from Bazooka's memory usage. There's a graph example. It supports Grafana, so you can do dashboards. Now we'll get to talk a little bit more about the data model. So if you're used to something like StatsD, it has this very hierarchical data model of trees of different things, where in Prometheus, we do everything with key value label pairs, very similar to Kubernetes philosophy. So we have a metric called the total request for, and we attach labels to get us the different dimensions, whether it's coming from which instance of a server, if there's a path involved in the API request, whether it's a get or a post or a delete, and then the status code of the response. So here's an example of how that would look in a query, and you can see that because it's label based, you don't have to worry about specifying all those stars. So it's much more flexible and much more efficient to just deal with the labels by expressing labels as matchers. Here's another example of what it would look like from our exposition format. So the way Prometheus gets data from your applications is it pulls with a HTTP GET, and it's just looking for this basic text, super simple to implement. We've already implemented this in a number of client libraries, and there is also a protobuf specification that will represent the same data. So when we were building Prometheus, they decided to go with a non-SQL query language, and it's pretty simple. You just it's inspired by the R programming language, so it's designed for handling lots of vectors and doing statistical analysis. So it's because that's what we were going for, was we wanted to be able to do statistical analysis and not just select data out of a table. So if you have a global counter for requests, you ask for the rate, and you give it a time range of what you want that rate to be over. So because the base metric is what's called an instant vector, and then but in order to take a rate, we have to turn that into a range vector by adding a time frame. In SQL, this isn't terrible, but it's, you have to specify a lot more stuff. Here's another one. This is taking the average temperature. So temperature Celsius is a metric that expresses a gauge of the current temperature, and this just gives you average by city. So you can easily do that. So how do you do that in a SQL-y thing? Yeah, that's not too terrible. What about this? So this is interesting. This is taking a rate of errors and dividing by the rate of the total. So this gives you an error percent automatically for a particular job. To do that in SQL, holy crap, that's terrible. It seems like SQL would be a good idea in the start until you start getting into the kind of cool things that you can do with the Prometheus query language, where you can just take one time series and divide it by another, or take one time series and do a join. You can do Boolean logic joins in Prometheus language. We like it a lot, but it is a domain-specific language to Prometheus. And also, like, in those SQL queries, well, you're just doing select all the time. Prometheus's query language is read-only, so there's no point in having a select. Everything is a select from Prometheus's query language perspective. Pull versus push. So Prometheus, we were very opinionated about pulling data from targets. So we had a bunch of discussion, and we keep having more requests for, we're always constantly getting requests for, how do I push my data into Prometheus? And we're like, you don't. Prometheus will get the data from your application. So your application has to expose the data to Prometheus. And we do this for a few reasons. We get automatic upness monitoring. If Prometheus can reach your target, we know that your target is running. So we get this automatic black box probe that your software is at least up and responding. From an ingestion perspective, an increase in traffic to your application doesn't actually mean an increase in traffic to your monitoring system. The monitoring system has constant input. You can, if you make a mistake in a label and you generate 1 million new labels, well, that's going to overload a Prometheus server. But normal traffic will never overload a Prometheus server. It simplifies HA. With a push system, every client has to be told which monitoring server or servers to send data to. With pull, the Prometheus server knows which targets to monitor, and the clients are dumb. They just sit there and wait for the request. So you can have 1 or 2 or 10 Prometheus servers monitoring the same targets, and it doesn't matter. So one of the things that people we like to recommend is people are like, well, is the new version of Prometheus safe? Well, just start up a new Prometheus server, run it, and if you like it, upgrade the old one. You don't, or just throw the old, go full chef design and just throw that VM away and let the new one run. But of course, it won't have any data. So yeah, it works really well. But there are problems with polling, and yes, you always have this problem where you might have targets that are unreachable. And this is a huge problem. We don't really have a good solution for this, but we have a bunch of recommendations for dealing with this problem. Back on this firewall situation, what we recommend is you run the Prometheus server behind the firewall and if you can, poke a hole through the firewall just to the Prometheus server. So the Prometheus server is the only thing exposed to the outside world. Or you can VPN to the Prometheus server, so you don't have to worry about that. Another interesting thing that's different about Prometheus is there's this thing that we call an Uber exporter. So Prometheus, you run a bunch of things on a server, and the Prometheus philosophy is application first monitoring, not server monitoring. So if you were to use something like Heroku or Amazon Lambda or one of the Google's variations of this, where you don't actually have any servers, so the whole serverless computing thing, Prometheus can monitor serverless computing because it can talk directly to your apps as long as the serverless computing provides a way for metrics to be counted. So you have a bunch of different things running on a single machine, and you have to talk to that machine. Everything has to be passed through this machine exporter. And this is not so great because what if that machine exporter is broken? Or what if one of the backends is non-functional and it causes problems for the machine exporter? It's not what we want to do. So it's an operational bottleneck. You can't scrape selectively. What if you wanted to scrape the MySQL server every minute, but you want to scrape the host stats every 30 seconds and the web app every 10 seconds? With Prometheus scraping directly, you get this. You can selectively change the frequencies. So this is the way we recommend people run things: is you always do one-to-one, where you talk directly to all the individual pieces of software. This leads, you have to configure your monitoring, so configuration management engines make this really easy. On the exporter side, we have our own custom format. Why didn't we use JSON? We tried JSON. It chewed too much CPU time. The text format is super easy. It's super efficient. It's readable by humans, and it's actually streamable. The protobuf, well, there's also the protobuf format. It's even more efficient, and it's also streamable. Yep, JSON sucks, at least for this for transporting metrics. I'm going to skip this. Relabeling is a fun thing we'll talk about later. On the client library side, this is actually a huge thing for certain languages, which is really, really hard, is if you have a running application, Prometheus needs to be able to pull it. But if you're, say, running PHP, that could be a huge problem because PHP doesn't keep any state between sessions. So when you connect to your PHP app, it has no idea what was previously running. So you have to push your metrics out of the PHP binary and into some other collector. Or say you're running Ruby and you're running Ruby in multiprocess. We're just finally getting our library fixed to use an intermediary mmap file to deal with updating metrics in a multiprocess situation. Everything is a float 64. Prometheus only supports one storage data type, which is float 64, and it's totally fine. We can pretty much do everything we want in float 64. No clustering. So distributed systems are hard. And you don't want something hard in your monitoring software. You want your monitoring software to be super reliable. So we completely leave out all clustering to keep the Prometheus server as reliable as possible. It's a little annoying to scale sometimes, but it's you can get away with a lot of neat things without clustering. Off multi-user, like I said earlier, we just don't. We're not good at it, so we'll leave that to other stuff. And now I'll get into a small case study of how did we take a big, huge Ruby on Rails application and add, and how did we go from our existing systems to Prometheus? So we had this at SoundCloud. We had this really big Ruby on Rails app, and it was quite a lot of different moving parts. We had statsd for getting metrics out of the application. We used Graphite to push the data into. We had New Relic to get even more data out of it. We had Airbrake for catching exceptions. I forgot to list, we also had Nagios checks in there. Eventually we upgraded from Nagios to Isinga. And it was a huge mess. And pretty much like the only real dashboards we had, well, so we had some dashboards, but you know, we actually got quite a lot of value out of New Relic. But New Relic was super expensive, and its cost scaled with the size of the site. And this was, we did the math, and it would have cost us several full-time engineers just to pay for a New Relic license to cover SoundCloud's needs for one application. And that's where Prometheus came in. So they started to build Prometheus to replace New Relic, because we ran New Relic, but we only ran it on the canaries. So we only had like 2 or 3 servers out of hundreds that were actually monitored with New Relic. And we just hoped that the other ones were working properly. And if you know anything about Google SRE, hope is not a strategy. So what did I do? So statsd is actually not a bad push protocol for getting data out of an application. So what we ended up doing is we funneled the metrics from statsd into a localhost statsd exporter so that we'd have less problems with the UDP packet loss. And then we could translate that into Prometheus. There's another utility called mtail, which I'll talk about. and MTail is reads log files and turns log files into metrics. And then the last one thing we did was we had the thing called the MySQL exporter, and we moved the database monitoring out of New Relic and directly into the database, so that we could get statistics directly from the database. So StatsD, one of the Prometheus developers, one of his first jobs was to take a look at how StatsD was working, and he discovered that because all the servers were sending their stats directly to the network off to the Graphite backends and the StatsD collectors, they were losing 70% of their events from StatsD. And they had to, because UDP packets, they get lost all the time. So as the traffic increased, the amount of the amount of traffic that they thought they were getting was only 30% of what they were really getting. And this was huge. So as soon as he fixed this to send the StatsD stuff to a local host aggregator so that those packets wouldn't get lost, they realized that they had tons more traffic than they thought they had. There's a little bit of some labeling and tree mess in the StatsD code because of the whole hierarchy thing, and then I added some. There's a thing called a StatsD Prometheus mapping. So before, you can kind of see here that there's different bits of the tree, and one subsystem counts hits and misses, and the other one counts total lookups and misses. So that needed to be cleaned up. So that was pretty easy to clean up. I changed everything to lookup totals and misses, and I normalized that tree. And then I could turn that into a StatsD mapping. So I take those starred things from StatsD, and I map those into Prometheus labels. And then now you have Prometheus labeled dimensional data coming from a StatsD source. Super useful. MTail is kind of a cool hack. It takes log lines, uses regular expressions to match patterns, and you can pull bits and pieces out of the log line and turn those into labels. And it's an open source thing written by a random Googler who needed something to do monitoring inside Google. And he added the support for the Prometheus output format in MTail. There's another similar one that I haven't done anything with, but it's called the Grok exporter. So if you're familiar with, I think it's Elasticsearch has a language called Grok, and you can use Grok expressions instead of regular expressions. So here's some example of the simplified version of the log lines in the software, and I could take and get some of these pieces out. So we have like the 200 OK, and we added a little hack to get the Rails controller and action into the log line, and we have this software origin, and it says it's an info, and we can get. We also have some timing information that we can extract. So there's a lot of good information we can extract. So a little bit of regular expressions later, we can create the number of log lines, and then we can pull out the controller, the software, the action, and the status, and we can collect the response times. So that we can now, and you can see you can either just plus the log line counter, or you can actually add, and so we take the milliseconds out of that log line and actually increment a time counter. And more recently, I've used they've made some improvements to the MTails expression, and I've actually generated histogram data out of this. So what do we do with that? Well, now we have some recording rules that can help us make it easier to deal with the data. So I can have a pre-computed rate that of the total responses by each of the other dimensions. And then I can take those responses and I can say, divide the total number of 500 errors and divide that by the total errors, and I can now do an error alert. And what do we also got some pretty dashboards, so we can have requests and problems and latency and everything. And we actually get this on a per controller basis. So every Rails app controller is now monitored individually. Here's another view. It was a more global view, so you could see which top 5 controllers are in use and which ones have errors, and look at their latency. And now I can do a quick demo. What do I got? I got, how much time left?
10 minutes.
Okay. How do I do this? There we go. All right, is this working? Yeah, it's working. All right. So, I've already pre-downloaded all the software. And so I'll just extract this Prometheus server, and let's take a look at that config file. So here's the basic config file. Is that font okay? That font's okay. And you can see that there's, maybe I will, yeah, that's a little better. There's a global config with a default scrape interval, a default evaluation interval which deals with the rules. There's a specification for rules files, so that you, which are separate config, and then the scrape configs is what things should be monitored. And by default, we ship it with a target file that contains scraping itself, so Prometheus server monitoring itself. So let's just save that, or leave that alone, and start it. Okay, it's running. What do we see here? Nope, can I type today? No, I can't. Hey, there's a Prometheus server, and what do we got? We have some targets, localhost is up. We can see that the Prometheus server itself is exporting its own metrics. Rules, there are no rules. You can see it also shows you configuration. And then we'll go back to this graph expression. So one of the things that I was talking about earlier was this concept of an automatic upness. And it's a built-in metric that exists for every target that Prometheus is monitoring. And you just say up, and it shows you which things are up. Well, that's boring. We need more stuff. So let's add something to this. Let's add the node exporter. Node exporter. Not complicated. So we'll start a node exporter, and now the node exporter itself is listening on 9100, and we can see that. Look at that, and we can see things like node CPU, and apparently my laptop has 4 CPUs. Yay! But Prometheus doesn't know about this yet. So we'll edit this Prometheus YAML and go down to the bottom and add a new job. No, 9100. And there's an implied, you can see that the metrics path is implied to default to to slash metrics. And so Prometheus is running, and we can just do a hup and targets. It's currently in an unknown state because it hasn't scraped it yet, but in a couple of seconds here, it's up. Look at that. So now we can go to this graph, and we can say node CPU. What do we got? There's all the data that matches this. And you can see that the metric itself contains two labels. There's a CPU and a mode label. And then Prometheus adds the instance and the job, the two things that are in the config file. So Prometheus automatically can add labels, and that's a much more advanced topic. But these are counters, which isn't super useful. So we should probably take a look with, say, rate. So let's apply a rate to see how many CPU seconds per second are in use. Looks pretty good. You can see idle time, user space, and we can graph that. But we're only running for a little bit, so why don't we take and crank this up to 11. So we'll add to this job a scrape interval of 1 second. And now we should be able to monkey click this and see a nice rate. Actually, what we can do is we can reduce this to, say, 10 and a 5-second average. And you can see it running. But there's this idle time thing. So we don't really care about the idle time. We want to care about all of the non-idle time. So we'll add a label filter, and we'll say mode is not equal to idle. And now we've taken that label and just dropped it. And you can see all the other labels. But that's still quite a lot of random lines in the graph. So let's summarize this. So sum, and now we can see the total amount of CPU time in use on my laptop as expressed by CPU seconds per second. If we wanted to see this as a percentage, we would have to take and do something like this. We would say count node CPU mode equals user. We'll pick one mode to drop the other things, and now we can see that it counts the number of CPUs. And you can see that works out pretty well. And so my laptop is not using too terribly much CPU time. Yeah. But what if we wanted to see this broken down by cores? Well, we can adjust this. Let's drop this count and actually show it as a percentage, or show it as a CPU seconds per second by core. So we can just say by CPU. And now we can see that CPU 3, CPU 1, CPU 2, and CPU 0 are all separated. And you can see those labels are left. We can also express this the other way. We can say without mode. So we can keep all of the other labels in addition. We've just aggregated without the mode. What if we wanted to see it by mode? We could change this from mode to CPU, and now we've dropped the CPU label but kept the mode, so we can see how much NICE, how much system, and how much user space CPU time is in use. Am I running out? All right.
Well, thank you very much.